So besides the earthquake, I'm going to be talking about a project that combines a lot of our research that we've been working on over the years in an interesting way. So we've had a long history of studying thermal comfort in the built environment, and recently focusing a lot more towards warm environments and overheating. Every day we read the newspaper, we've set a new heat record. So that's kind of a direction we've been going. And of course, air movement and fans has been another topic of research for us. And this project combines the two in a really fun way, interesting way. It's a great example of working with a CB partner on a research project. And so this project primarily funded by Big Ass Fans, and not just funded by them, but also really helped organize and get us into a location to do a really unique study in an actual manufacturing environment, which is quite a challenge. Our goal was to look at the impact of using fans to reduce heat stress in a factory in a hot, humid climate. And so we spent a total of 6 weeks in Baton Rouge, Louisiana. We had 30 workers participate in this study, and we were measuring lots of things in the building with people over these 6 weeks. And we basically were running half the time with the fans on, half the time with the fans off, and looking at the impact of that on the workers. We collected a lot of interesting data from that. I'm going to be showing you some of that today. We're still working through the data. We're done collecting it all in the field study, but we're still processing today. There's a lot of interesting stuff to figure out. But I just really want to point out the collaboration with Big Ass Fans and Madison Air, their parent company, in setting this up. But the factory we worked in was a part of their family of companies. So that was the opportunity to work with them. And we had really good cooperation with them to get this study down. Really unique and valuable research. So the work took place in these steel manufacturing buildings in Louisiana, as I said. They're single-story, non-air conditioned buildings. Very challenging buildings to air condition. They have big, wide door openings that forklifts are moving in and out. They're building large equipment. So hard to air condition these buildings, expensive and difficult. This is what it looks like inside one of the buildings. You can see a lot on the manufacturing floor, stuff that's being manufactured. You can see the Big Ass Fans in the ceiling there that they recently installed. So they have both ceiling fans moving a lot of air, and then also some more wall-based fans providing local air movement for the workers. The facility manufactures primarily HVAC-related equipment, enthalpy wheels, heat recovery, air handling systems. They're building, generally speaking, large things that take several days or even a couple of weeks to build. And they're doing welding and sheet metal work and cutting and electrical work, lots of different kinds of stuff. So challenging in terms of looking at the effect on productivity, because it's not like they're making 300 widgets one day and make 295 the next day. We look at that difference. They're doing different work every day. So not an easy task there, but really interesting and valuable kind of work that they were doing to test the fan benefits of the fan. So the way the protocol worked is each day we had a morning and afternoon, and then we would either have the fans on in the morning and off in the afternoon, or off in the morning and on in the afternoon. And that allowed us to compare afternoons, which tended to be warmer inside the building than the mornings, with the fan on and fan off, and also compare the mornings where it was a little bit cooler with the fan on and with the fan off in these different areas. We collected physiological data for the people, which were body temperature, just with a temperature sensor like you'd use at the doctor's office under your tongue. They were heart rate monitors, so we're tracking that during the day. And we're also estimating sweat rate, which I'll talk about in a second. The workers responded to a survey several times a day. We'd walk around, as you can see here, Chung Wei's had taken someone's temperature, and she'd have a tablet. And they'd answer a few questions about their productivity, about their comfort during the period of either the morning or afternoon. We're also measuring, of course, the environmental conditions, outdoor, indoor air temperatures, humidities, and the air velocities with the fans on and off. The sweat rate's a really interesting one. The idea is that if we can account for everything going in and out of your body, any change in weight is basically due to sweat loss. And if you're working hard in a hot, humid environment like this, you might lose maybe a couple liters of sweat. So it would be maybe up to, say, 4 pounds of water. So it's a measurable amount. But the trick is you need to be very careful about tracking all these things going in and out of your body, which is no small task. But each subject was weighed when they got to start their shift. We weighed them before and after every time they used the restroom. We weighed them at the end of the session, and then we also tracked everything that they ate and drank. So we measured their water bottles as they refilled them, all the snacks they had, we'd measure and track all that in a spreadsheet. So the idea is to carefully, measure all these things, and any difference in their weight is just from the sweating alone. Easier said than done, I'll say that, just because we have a factory there, people are working, they're going out, they're having a drink, they forget to tell us they're refilling their bottles. So there's a lot of moving parts here. But in general, it was I'd say a very complicated study. All the workers are doing different tasks all the time. Their metabolic rates are changing as they're doing different activities. Tracking, as I said, all this food intake is not an easy thing. The volunteers in the study were certainly very supportive and wanting to do the right thing, but it's just they're trying to get their job done. And it's easy to forget to get on the scale or to measure a snack. So the other problem we had is that it was a big factory with maybe 100 workers total, and only about a quarter to a third of them were participating in the study. So in areas where people were not participating, the fans were running all the time. And so it was hard to coordinate. People weren't always in the same spot. So sometimes they're moving to an area where the fan was running. So maybe they're actually being cooled by a fan, even though the fan is supposed to be off. And then the other thing we realized is that workers clearly adjust their level of effort based on their heat stress, right? So if they're feeling a little bit more comfortable, they might work a little harder, raise their metabolic rate. And so there's a kind of a trade-off there. We kind of self-regulate. And since we didn't have control, like you might in a laboratory study, of what the person is doing in terms of their metabolic activity, that's another complicating factor. And then we're measuring their temperature. If they have a cold drink, and then you measure your temperature, you're just going to be pretty low. If you have a cup of coffee, you measure your temperature, it's going to be high. So we have to really coordinate when they're having a hot or cold drink relative to when we're measuring their temperature. I like to think about this grid of laboratory studies and field studies, and then buildings and equipment and human subject studies. So the easiest studies that we do are ones that are in the lab, or we're measuring a piece of equipment or something about the building, which is kind of easy to control. And the most difficult one are field studies, where we have human subjects involved. And as a result, those are not only the hardest to do, there's very few of them. So this is super valuable from that context, because there's just not much work done like this, where you're in a real environment with people trying to measure impacts. So to give you an idea of the weather in Baton Rouge when we were there, this is the August part of the study. So here's 3 weeks. They work 4 10-hour-a-day shifts. So what you're seeing here is the black dot is the average daytime temperature. This is their shift is basically 6 a.m. to 4 p.m. And then the blue line is showing you the range of temperatures. So you can see average temperatures sort of in the high 80 degrees Fahrenheit, sort of the high 20s Celsius, with peaks up around 95 degrees Fahrenheit for most of those days. If you look at the heat index, if you're not familiar with heat index, if you're from a dry place like California, you might not hear that very much, but if you're from Louisiana, you probably do. Heat index is a way of combining the temperature with the humidity to sort of a feels-like number. And the heat index was up in around 105 degrees for the first couple of weeks we were there. You can see the heat index drops that third week. The humidity decreased a bit then. So even though the temperatures were not that different that last week, the humidity was quite a bit lower, so that made the heat index drop. The Weather Service and OSHA developed this heat index system of tracking, what's dangerous and what's safe in terms of the heat index. And so you can see that from the 105 degrees Fahrenheit and above is the danger zone for heat index. So right in that edge of where it's starting to become dangerous from the National Weather Service perspective of heat index. So it's hot. It's a difficult, challenging environment. Looking at the indoor temperatures, you can see that the red dots here now, I'm just keeping the weather data there. The indoor temperatures were significantly, the hot peak temperatures indoors were warmer than outside. We have a lot of machinery, people inside these buildings, solar load on the roof. So the indoor temperatures are actually warmer than the outside temperatures in terms of peak temperatures. We also measured, we used one of these, a radiant temperature sensor, which is an infrared camera pointing 6 different directions to measure the radiant temperatures in the building. And I'm plotting here the purple dots on the top here are the maximum ceiling radiant temperature. The ceiling on one of the buildings in particular was uninsulated, has a metal roof. It's getting really hot on a sunny day. You can see those radiant temperatures up around 110, 100, almost approaching 115 degrees Fahrenheit. So that's a big radiant source of heat gain for the people working underneath these as well. So hot, pretty challenging conditions. So I'll walk you through some of the preliminary results here. To start with the survey data, which is kind of the easiest to analyze. And so some of these questions, this first group of questions are ones we asked at the end of the study, looking back for the participants, asking them how important was it to have the fans running in their workplace. And so we gave, this is a 7-point Likert scale. Essentially, no one is below the either strongly agree or agree, right? Everyone's either absolutely or a little bit, but no one's even somewhat or neutral, no votes there at all. So it's very, very important, obviously, to people to have these fans in the workplace, making a big difference. We asked a kind of a self-assessed productivity question. So compared to when the fans were off, when the fans were on, how effective were you at your job? And more than half the people are saying they're much more effective, and 3/4 of people, 80% of people together either are much more or a little more effective at their job. So a big impact there in terms of how people assess the way they work. Not surprising, but great to have the sort of, the data in hand. Now those are sort of looking back at the overall survey. These are some results from the survey we gave them. We walked around asking right now, over the last 2 hours, how have you felt? What's your thermal sensation? So we're looking here at thermal sensation now grouped by when the fans were running and when the fans were not running over the afternoons in the session. So you can see there a significantly higher thermal sensation with the fans off compared to when the fans are on, right? It's a pretty substantial difference there. With the fans on, you never get above that hot vote. With the fans off, many people are at that hot and above vote. So almost over a scale and a half to a degree difference between the fans running and the fans not running. Air movement preference. So this is the question, I would like to have more air, a lot more air, a little more air movement, no change, a little less or a lot less air movement. When the fans were, this is again asking the right now during the day questions, when the fans were off, 90% of the people saying I need a lot more air motion. When the fans are on, even then we still want people with, want more air motion, even though we're measuring a lot of it. There's a lot of air motion. These fans are really working well. It feels pretty good. We measured up to 4 or 5 meters per second. For those of you who are familiar with kind of fan air speeds, it's a lot of movement. Typically in a building, you might have 0.2 or 0.3 meters per second. But even then, people still want more air movement, but it's still significantly reduced, obviously, compared to when the fans are off. So now look at some of the physiological data. This is the body temperature, so core temperature, comparing when the fans are off to when they're on. So we measured this in the afternoon. We measured the temperature and asking these questions at 1 o'clock and then again at 2:30. And then at the end of the shift at 4, we did measured the body weight to get the sweat analysis. So you can see here, when the fans are running, the core temperature at the 1 p.m. average is a little bit lower. It's right on that sort of 98.6 typical value, a little bit elevated with the fans off. But you can see then by 2:30, the temperature rise is significantly more when the fans are off. So we're measuring a real physiological difference here in people's response with the fans running. So, and so we'll be doing more of this analysis moving forward with more detail, looking at the actual temperatures in the spaces, not just bidding them together like in this graph. But it's exciting to see we have that signal, a measurable signal from the data. And then the overall impact, I would say, is just the comments from the workers. I mean, we got a lot of interesting response from them. They're really happy to have these fans going, but you can just read sort of the kinds of impacts that it makes on them. It really makes it easier for them to do their job when these fans are running in a significant way. We also had a lot of media interest. It was interesting. So Christine Carey, who's here with Madison Air, did a lot of good PR for this, and we had 2 local TV news stations showed up to do some interviews with the team doing the research, as well as the participants in the study. So that was fun for everyone. And then they're also making a video of the whole project that at some point will be available. We're looking forward to seeing that. So with that, I'll wrap up. I'll take questions. I just want a big thank you to Big Ass Fans for both providing the financial support, but also the coordination of finding the site and arranging that support. Chung Wee spent 6 weeks in Louisiana, it was not an easy job, I'll say that, because we had to be there at 5:30 in the morning before the workers got there and stay till about 6 o'clock at night every day. And it's nonstop action with 30 people trying to get them all weighed and before and after every time they go to the bathroom and snacks. And it was a little bit chaotic. So we also had it's a great collaboration. I forgot to mention the first slide, but with the University of Sydney in Australia with their team, Ollie J, and we had James Smallcombe and Glenda Anderson who joined us on site for part of the study as well. They have a lot of expertise with heat stress and field studies, so that was really valuable to get their input in cooperation with that. So we enjoying a nice meal after the end of the project. So great. So I'll ask any questions you have now. I'll take those.